Hi, welcome to Jerry's Detectives, where technology meets Jerry. In today's episode, we're going to learn about these equipments, the function generator and the oscilloscope.
Done.
Before we begin, let me welcome my friend whose expertise is on this field, Mr. Kenji Tanaka. Hi Kenji.
Hello?
Kenji, I have friends who has quick questions about this equipment, so can you teach them?
Yeah, sure.
Okay, so let me welcome you, my friends, my guests, Amiel Baldivisco and Mark Rafael Villanueva.
Yes, sir.
Oh sir, what is function generator and what are its uses?
So a function generator is the one that we have here. Is an electronic test equipment that we use to generate electrical waveforms over a wide range of frequencies. And it is normally used for the development, test, and repair of electronic equipment.
And what about this oscilloscope, sir? And what are its uses?
So an oscilloscope, the one that we have here, is also an electronic test equipment that basically allows us to observe constantly varying signal voltages, usually as a two-dimensional plot that allows us to observe the period, frequency, and amplitude of the signal that we are measuring. So its uses are basically just like a function generator as for the development, test, and repair of electronic equipments.
So, sir, basically, how do we use these equipments?
So I'll teach you guys the basic operations of these electronic test equipments, and in our experiment for today, we'll use this function generator in order to produce an electrical waveform that we can confirm through our oscilloscope right here. So basically we can confirm the frequency, amplitude, and period of the signal that our function generator generates. So before we begin, we must first turn on our oscilloscope in our function generator. And in our experiment for today, we'll be using this function generator in order to produce an electrical waveform that is of frequency 100 Hz and in a sine shape. So as you can see, our oscilloscope had plotted that signal. And each division in this screen, or each line in this screen, represents a division. So in the settings of our oscilloscope, we have set there as 0.5 per division. We'll use it later in order to measure the amplitude of our signal. And we have also here set as 2 milliseconds per division. So in order to gain some useful information on this graph, we must first align this so that it would be easier for us to identify crest to crest, trough to trough, or anything so that we can see a cycle. So we'll have it here. So it'll be easier for us. So in this case, we'll be measuring the crest to crest. So it would be 1, 2, 3, 4, 5. It would be around at 5 divisions. So as you can see in our settings here, as you can remember, we have 2 milliseconds per division. So that makes the cycle of this waveform to be at around 10 milliseconds. So as you can remember in your physics class, the frequency is equals to the inverse of your cycle or period. So that would make to 1 over 10 milliseconds. So that would be equal to around 100 Hertz. As you can see, we have set here in our function generator to be at 100 Hertz. So we already know how to get the frequency and the period of a signal using our oscilloscope right here. So right now we will be measuring the amplitude of the signal. So the amplitude is basically equals to the distance from the midline to the crest or trough. The crest be the highest point and trough the lowest point. So in order to make it easier for us to measure the amplitude, we'll just measure the distance from the crest to trough and equate it to twice the amplitude and divide it by 2 later, so we would get the amplitude. So we'll adjust here so we can measure the distance from crest to trough easily. So, yep. So it is around 1, 2, 3, 4. The distance between the crest and trough is about 4 divisions. And as you can remember in our settings in the previous minutes, our oscilloscope had been set into 0.5 volts per division. So that makes twice the amplitude of our signal right here be equals to 2 volts. So we will divide it by 2, so the amplitude of our signal would be equals to 1 volt.
Thank you for your time and expertise for this episode's experiment, Mr. Kenji Tanaka.
It's my pleasure.
Thank you, sir.
It's my pleasure.
Thank you very much.
My pleasure.
And I'd like to thank our fellow viewers out there. And if you want more tutorials, please like and subscribe and share. Thank you. Goodbye.
As an electronics engineering student, this is really helpful for me in order to know how to operate an oscilloscope and a function generator, just like what we have shown in our video presentation. As a future electronics engineer, it's truly helpful for me in order to improve my efficiency in designing and developing electronics and electrical circuits.
What I have learned in this experiment is that the function generator and oscilloscope are an important tool when it comes to analyzing and debugging circuits. They are particularly handy when it comes to measuring amplitudes, frequencies, and transient signals. So having this experiment is very significant and helpful for me as an engineering student because through this lab experiment, I slowly figured out how to properly use the machine and how each knob works. So when I had my first glance at the equipment, it was very complicated to understand and difficult to master, but when I slowly studied the equipment, it was worth it.
As an ECE student, getting to know some equipment used in electronic and circuit laboratories are sure interesting and will sure develop and harness our skills for the future. In our experiment, we used a function generator oscilloscope, and I learned that function generators are signal sources which provide specifiable voltage applied over a specifiable type, such as sine, square, triangular, or sawtooth shapes. And oscilloscopes are a type of signal analyzers. They show us a picture of the signal, usually in the form of voltages versus time graph. So we can study these pictures to learn the amplitude, frequency, and the overall shape of a signal, which may depend on the physics being explored in the experiment. So on the experiment we've done, we do some basic steps using those two equipments. And using it wasn't easy. It takes a good deal of experience to learn how to operate them well and take full advantage of their capabilities.
As an electrical engineering student, these two equipments, the function generator and the oscilloscope, are quite helpful to measure the frequency, the period, and the amplitude of a certain material or circuit. It is quite complicated to study. As long as you practice with each button and function, you'll be able to master it in days or weeks.
Done.